Hi, everybody. I realize I'm the last session, so I will try to keep it quick. I'll try not to ramble on too much. But yes, my name is Jackie Sweet. I'm the lead software engineer for Dr. Tavel Optical Group. I'm here to, again, briefly talk about our slightly left field, I'd say, use case in confidential computing. And now to use this. OK. So first, a little bit of history. Dr. David Tavel was an optometrist by trade, served in the Army during World War II, promptly opened his first optometry office in downtown Indianapolis as soon as he came back from war. His real claim to fame here, and what really set him apart in eye care in the United States at this time, was same-hour service. And what this meant was you could walk in as a patient, get an eye exam, and walk out with a new pair of frames and lenses made specifically for you with your prescription. Now, this may not seem like a huge deal, I suppose, these days with things like Amazon same-day delivery and whatever other type of super convenient technology. But in 1947, which is, I believe, when this started, I think they may have still been using carrier pigeons to perform long-distance communication and whatnot. So this was nothing short of revolutionary in eye care. This was a pretty big deal. And I think David really pushed to do this because he had a very firm belief in providing quality eye care and access to eye care for working class people in Indiana. This is what he built the foundation of his business on. Fast forwarding to today, David is, he has since passed away. His son Larry has been the owner of the company for close to 45 years. And I think he feels still just as passionate about driving forward eye care with innovation. And with that, using technology in the best way that he can. At the time, it was building labs inside of doctors' offices. That obviously didn't scale for that long. As he scaled out his offices, I think it became clear that it was really expensive to have all these decentralized laboratories everywhere. So today we have our own central lab right next to the corporate office in downtown Indy. And the vast majority of eyeglasses are still manufactured, assembled, and shipped out from there today. A few years ago, Tavel created Tavel Technologies, and that's the group that I'm part of. And the main goal in Tavel Technologies, that, at least how I like to put it, is we're trying to grow this traditional brick and mortar business with new modern technology and try to bring it out of what I would call the dark ages. They may not like that I say that, but anyway, so we've been using technology to do things like simply just investing in better laboratory equipment, better software that doctors use, software for reporting and analytics, things like that in the corporate office. We've invested heavily in an online presence, so our website, doctor-patient communication via alternative methods like text messaging, booking appointments online, things of that nature, which, again, you may not consider that big of a deal, being that we're at a tech conference. But in eye care, for some reason, I feel like they've really lagged behind when it comes to technology. That's not to say that eye care itself, in terms of laboratory equipment and treatment, hasn't grown. It certainly has. LASIK, for example, it's very different from what it was in the 90s. But the software that small to medium-sized chains are using, and they're using this importantly to engage with patients, can be really antiquated. And so that leads to the third growth area that I hold very dearly, which is patient-to-office associate interactions. So by that, what I mean is we're trying to leverage technology in a way to enhance the overall experience that a patient has from the moment that they walk into an office to the moment that they leave with their new pair of eyeglasses or contact lenses or whatever. To elaborate a little bit further, I'll talk about the main software system that we're targeting right now to enhance, and that's the POS system. Really nothing all that special, but the POS system in an optical chain is the the bloodline of the office. It's used for all patient engagement, managing all of their appointments, their notes, all their orders, transactions. It integrates with the electronic medical records. It integrates with the laboratory software. And interestingly enough, for one reason or another, the vast majority of eye care companies have been stuck with really old legacy on-premise installation POS systems. A lot of it's interestingly dictated by insurance companies, but we don't need to go super political about this. But the point being that Tavel and many other similar optical chains don't really have a choice in the POS system that they use. So instead of fighting it, we're trying to alleviate the situation by building software that complements it. Because again, what we want to do is enhance that experience between the patient and the optician. So over the past year, I've been working on, I suppose I'd call it a software suite that again is meant to lay on top of this POS system as the first integration point. We're calling it CoApp. And the point of CoApp is to provide additional context when an office associate or an optician is sitting there in front of the patient so that they can spend less time staring at a computer screen and more time looking you in the eye and trying to understand what you need, what best suits your lifestyle when it comes to eyewear. So CoApp has 4 fundamental pillars of functionality: error avoidance, contextual guidance, information enrichment, intelligent automation. Basic example I'll give with error avoidance is something that's really common, and CoApp is actually deployed today across our offices with this specific rule in mind. And that has to do with aspheric prescriptions. So a person is considered to have an aspheric eyeball if certain measurements add up to certain numbers. So if the left cylinder diopter plus the left sphere diopter is greater than or equal to 3, or less than or equal to -3, same thing on the right side, they would be considered to have aspheric eyes, or at least one. So it would be recommended that the lenses ordered for a patient would qualify as aspheric lenses. They're just made slightly different for that shape, that relatively irregular shape of an eyeball. The POS system, interestingly, doesn't detect that type of error, and there are a lot more nuances in Eyecare where the POS system fails. And the problem is you can train humans as much as you want, but they're always going to be introducing errors. And when they introduce errors into the POS system and order the wrong materials for a patient, the patient is who suffers. Because then we have to call them and say, actually, we made you the wrong thing. Actually, your insurance isn't going to pay for it. Actually, we're being terrible, and so you have every right to hate us. So CoApp comes in and is meant to provide this extra error avoidance in this case. And so what this means with my really beautiful diagram is that we have 3 components that make up CoApp. First being a rule builder, and this is just a basic web application that has a pretty interesting rule engine and rule building mechanism for office managers to go in and build rules to deploy across workstations in offices. So that aspheric rule, they'd literally be able to type in, if the left sphere plus the left cylinder is greater than or equal to 3, et cetera, et cetera, et cetera. These rules get deployed to a Chromium-based browser extension that's installed on all of the workstation computers in the offices. This browser extension essentially functions as a rule interpreter. Great, so it reads the rules, scrapes the page as the office associate is working through the POS, adding in this order, and then it reacts appropriately. A pop-up shows up and says, hey, there you have an aspheric prescription, you're ordering the wrong lenses. Or hey, Susie's children also have appointments coming up next week, and you're scheduling her for 2 weeks from now. Do you want to try to combine the appointments into 1 2-hour slot? Something a little more helpful that isn't necessarily an error. And the third component, and the reason why I'm here today, is the confidential application. So what we found was moving outside of Tavel, which is what we fully plan to do, the browser extension can only see so much. It can only see what it sees real time on the web page. It's relatively useless in that regard. So in order to provide it additional context that it may need to execute these rules and logic that would be really, really helpful in the office setting, we have an application that simply opens up a connection to the on-premise database that we know exists at Tavel. And it essentially functions as a tunnel to bring that data down to the browser extension so that it can also analyze that data and react appropriately. So all of a sudden, the extension has access to appointment information, information about Susie's dependents, previous prescriptions or previous orders. And the problem that we were facing once we built a prototype of this was, well, when we move outside of Tavel, because again, this is what we plan on doing, we're not the only optical chain that suffers from super inadequate software. We don't really want to have a hand in their PII. We don't want to have access to their data. We obviously don't want to collect it. We just want, we've built a rule engine, and that's what our application developers are focusing on. We don't want to have to worry about confidential data that we have no business of ever seeing. And so honestly, this requirement was posed to me by higher up people at Tavel. And I was a senior engineer, and they told me, you have to find a way to build this thing so that we can obtain data, process it, but never actually see it. And my gut reaction was, well, I mean, you can't do that. Data's encrypted at rest and in transit, but once you're doing something to it, you can't, somebody has access. Somebody always has got access to this data. So I ended up going through a tangent of exploring always encrypted databases, homomorphic encryption, and eventually stumbled across confidential computing, which I'm really grateful for, because I think our use case, as you've seen, is actually really simple. All we're doing is extracting data and then sending it to the client where it's trusted because it's on their computer. But it's really critical for this to advance outside of Tavel. Without confidential computing, I think we'd have a really hard time moving forward. So right now, we basically have a prototype of a confidential app running inside of Nitro. As you saw in the diagram, we're using AWS as our cloud provider right now. That may not necessarily be the case going forward. We're still figuring that out. The browser extension features this onboarding procedure, and we have a rudimentary attestation service that we built ourselves to ensure, so that the browser extension can ensure that it's continuing to communicate with what it thinks it's communicating with. Again, I think moving past this, and one of the reasons why I came to this conference was to learn about what our other options are, because we are essentially going to be a consumer of confidential computing. I think we have a perfect use case for it. We don't want to be in the business of building something custom, even though I think that would be great, but we have a lot of work cut out with the rules engine. And so anyway, I think there are a lot of other folks that probably fit into the same bucket as us, but maybe just don't even know that confidential computing exists yet. I can't imagine that I was the only one. That's all I've got. Thank you.